Good morning to everyone. We are discussing the fundamentals in object-oriented exception handling a framework. Exception is a runtime error. Exception, that is a runtime error, can be handled in two ways. One, user-generated exceptions, and another one is system-generated exceptions. So some of the user-generated exceptions as well as system-generated exceptions are going to be handled by the user using object-oriented exception handling framework. In that we have discussed throwable. What is throwable? Throwable is the superclass of all other exception classes in Java. Then below the class throwable, we have classified some subclasses. They are exception and error. Below exception, we have classified runtime exception, then arithmetic exception, some of the subclasses of an exception class. We have seen some of the exceptions, say array index out of bounds exception, negative array size exception, illegal access exception, null pointer exception, string index out of bounds exception, divide by zero, that is arithmetic error exception. The error, runtime error, which can be handled using object-oriented exception handling framework. Because the exceptions can be thrown in two different ways. One, user can throw the exception. Second, system can automatically generate the exception. So whichever is either user generated or system generated exceptions. Other than the stack overflow, some of the runtime error cannot be handled by using the proper user defined tool. Other than that, all user defined exceptions and the runtime exceptions can be handled through the proper user defined code. We have discussed the syntax of try and catch blocks. What is the syntax of try and catch block?
For each try clause, there will be at least one catch clause.
Each try block, we need at least one catch exception handler. The program statements that we suspect for some exceptions, runtime errors, can be placed inside the try block. Then the corresponding runtime error can be handled using exception handler. So try, if you suspect write even at least a single statement, that should be enclosed within opening and closing curly brace. Try, opening curly brace, statement 1, then closing curly brace. We can enclose a block of statements also within a try block. Following that, we need to define the catch exception handler. Catch exception handler 1, exception handler 2, etc. Exception handler M. When there is a runtime error reported inside the try block, the control is first tested against the exception handler 1. During the match between the raised error and the exception handler, the specific exception handler alone will get executed. Then remaining exception handlers are bypassed. Control goes to execute the next statement following the last exception handler. In between the exception handlers, you are not allowed to define any executable statements. So when there is a mismatch between the exception handler and the raised exception, then it goes in the sequential order to check for a matching. In case if there is a no match between the raised error and any of the exception handler, that stage that Java's default exception handler terminates the program execution and prints the corresponding state trace value. This is the basic syntax of a try catch block. When defining the exception handlers, catch corresponding to the try block, what we have to do means we need to ensure the exception classes, right? Exception classes are to be followed in some order because all exception handlers are defining the exception classes. The exception classes should be defined with respect to some order. In case If there is an exception subclass name, exception subclasses must come first, and then exception superclasses should be defined. For example, arithmetic exception. This is a subclass of a superclass called exception. Arithmetic exception. Then you need to define exception. In case in the reverse order, if you are defining the superclass exception, can capture all of its subclass exceptions plus its own exception. So that stage, control will never go to execute, say, arithmetic exception. That results in a compile time error. Hence, you should remember that exception subclasses must be defined before any of its exception as superclasses. This is very important order. Then we have seen the nested try-catch statements, like a class, like a for loop, like an interface. We can define one try-catch block inside another try-catch block. The rules are right as simple. When there is a runtime error reported inside the outer try, control goes to check against outer exception handle. Outer try, outer exception handle. During the match, the specific exception handler alone will get executed. Then control goes to execute the next statement in the sequential order. In case when there is a mismatch corresponding to outer try and outer exception handler, then default exception handler terminates the program execution and prints the corresponding state trace value. Outer try, outer exception handler. Then coming to the inner try, when there is a runtime error reported inside the inner try block, the control goes to check the successful match against the raised error with the exception handler defined in the inner try block. It tries. In case if there is a success, right, then the specific exception handler alone will get executed, and then the sequential execution is taken place. In case if the raised error inside the inner try block does not match with the corresponding inner exception handler, that stage control is transferred to test against the raised error of a inner try with the outer exception handler, outer tries exception handler. During the successful match, right, what will happen is the specific exception handler alone will get executed, and then a sequential execution is taken place. If not, inner try exception handler, right, uh, doesn't match with inner tries runtime error, then outer tries exception handler does not match with inner tries runtime error. That stage, what will happen is Java chooses to terminate the program execution and prints the state trace value, that is by executing the default exception. And that is the role of a nested try-catch blocks. Try-catch can also be nested, placing one try-catch inside another try-catch block. Then finally, we have seen a throw keyword. In some situations, we can throw the exception manually out of a method, so that to the caller of a method we can throw the runtime error. For that purpose, we need to use the throw keyword. The syntax of a throw keyword is this one. Simple syntax: the throw, a throwable instance. Throwable instance must be the object of, right, a throwable class or any of its subclass objects of a throwable class. Other than the subclasses of throwable or a throwable object, we cannot use the throwable instance. For example, we cannot use the throwable instance for the fundamental types or some non-throwable classes, say string, object class. This cannot be used as a throwable instance. How to create a throwable instance? We have seen there are two different ways of creating a throwable instance. One, we can directly use the parameter of the catch class, say arithmetic exception AE. right? We can directly throw AE. Null pointer exception, suppose NPE. NPE can be directly used in a throw statement. Throw NPE. This is one possible way. So whatever the instance we have created using the catch exception handler, that instance can be thrown easily, right? Using this general form, a throw throwable instance semicolon. Another possibility is the throwable class or any of its subclass of throwable class must be instantiated using the new operator. Throw new. After that, what you have to do means you need to use the exception class. The exception class, this must be a throwable class or any of its subclass of throwable class. Then if you need, you can pass the constructor value. Throw new exception class constructor. Exception class must be a throwable class or any of its subclass of a throwable class. It seems unconditionally the statement throws the runtime error to the calling place, or this can be the error is thrown out of a method. In that stage, what will happen is throw unconditional throwing of a runtime error. Following that, we should not have any executable statements, because in Java, if there is any statement which is not to be executed, that results in a compile time error. For example, in C and C++, you might have seen the return statement like this. Return, suppose a function f is defined, return 1, return 2, a function, say void f. This is a valid function definition in C and C++. Void should be removed to int. Okay. Printf, return 1, return 2. You can use any number of return statements. Once the control reaches the first return statement, the value is returned to the calling place. It will never go to execute the subsequent return statements, if any. Where in Java, the same concept, for example, printf method name, return 1 then return 2 means once the control goes to execute return 1, value 1 will be returned to the calling place. Control will never go to execute, right, or return 2. So this is taken as unreachable code. We try to check this unreachable code in Java. Java compiler detects unreachable code. That stage it results in the compile time error. So following this return 1, if you specify any other executable statement, that results in the unreachable code. Likewise, following the throw statement, if you define any other executable statement, completely taken as unreachable code, that results in the compile time error. So this is a flow of execution of a throw statement. For example, consider this class, say class exception 8. And we have defined one class throw E. In throw E, one method is defined. Inside this method, we define the exception handler, try catch. In the try block, unconditionally, we are throwing the runtime error, say null pointer exception. You can use any class, which is a throwable class or any of its subclass of a throwable. One constructor message is given. Following this, right, if we have any executable statement, that results in a compile time method. The try block is enclosed, right? Try block is defined. This exception handler, catch exception handler. Catch null pointer exception. Null pointer exception. The instance value is entered here. Then if you need, right, you can rethrow this exception to the calling place. Coming to the main, a throw E th object is created for the class throw E. Then inside the try block, we are calling th.method. th dot method means a control goes to call this method. So statements are executed in the sequential order. After this message, we are throwing an exception unconditionally. So this will be caught in this exception handler. Catch null pointer exception. So understand the usage of throw keyword requires the try catch exception handler. This is a rule. Now this runtime error is thrown within this try block, or you can consider runtime error is reported inside the try block. Now this will be checked against this exception handler catch. There is a match between this exception and this exception. In case there is a mismatch means Java terminates the program execution. So here during the match, this line will get printed. Then in case if throw any is commented out, no problem. Then the subsequent statement right here after the method call, this line will get printed. In case if you remove this command, throw nv, and calling the method, this method, the runtime error is reported and it will be caught in this exception handler processed. Okay. This throw NE follows the same syntax, right? A throw throwable instance, which means we are rethrowing, rethrow the same exception to the caller. The caller is a th.method. So this highlighter statement results in runtime error. The received runtime error is null pointer exception. Since this line results in a runtime error, this runtime error is tested against this exception handler. The exception that you have rethrown from this catch exception handler is again recaught in this exception handler in main catch. Following that, the sequential execution end of main method is activated. This is the usage of a throw keyword. Following the throw keyword, we have another keyword that is throws one.
Sir, I have a doubt in exception 8.
Yeah, tell me.
Sir, in main method, inside the try block, the second statement after the function call, will it be executed or not, sir?
This one
Yes, sir.
after call, this will be executed if this line is commented out. Throw any is commented out because after this line any is something, then the exception handler handled the complete exception, no problem. So th dot method results in error. Runtime error is processed or caught in this exception handler. Subsequent statement after calling th dot method will get executed. Java C, Java C, okay, we need to decompile. Exception 8 dot Java, Java exception 8. What is error message? Class, okay, error message. Java exception 8. Inside method, then any is error message is printed. You can see the message after calling th dot method. In case if you throw any is available here, that stage what will happen? The runtime error is processed in the exception handler. Further, the same error is rethrown to the calling place. So the calling statement results in a runtime error. So you cannot see the message after calling th.method. Instead, this runtime error will be caught in this exception handler catch. So I cannot see the message after calling th.method at this stage.
Understood, sir.
Clear?
Yes, sir.
Okay. In the next one, we are moving on to throws keyword. Understand clearly, Java has two types of exceptions.
Sir,
One is checked. Yeah, one is, yeah, tell me.
sir, here also the message that we print is also the unreachable code only, so then why it's not throwing an error, sir?
Which line? 1 minute. In exception 8.
Yes, sir. When we read through the exception to the caller,
Okay.
the message to be printed is unreachable code only, sir.
And it's not an
In the
unreachable code.
main
We are
method, sir.
rethrowing main method. Which one?
ts dot method. After that, we are printing after calling ts dot method, sir.
Calling method. Okay, okay. Good question. Right, I explained. Okay. When this is not commented out, okay, throw ne. Throw ne means th dot method calls this one. That stage error is processed here. Further results of throw ne results in compile time error. So results in a runtime error. So because of this runtime error, the control goes to execute this exception handler. Your question is right, why the unreachable code error message is not coming? Because of the statement will never get executed. Right?
Yes, sir. Yes,
Here
sir.
we are processing in terms of exception handling. But in the normal sequential execution, if you say 100%, the subsequent statement will never get executed, then that is the logic of unreachable code. For example, following this throw statement, if you have the system.out.println, now what will happen means once the statement will get executed, then control goes to execute the statement. So 100% the statement will never get executed. But as far as this method call is concerned, method call may complete its execution or method call may not complete its execution, right? Because of this exception handling framework, when you are rethrowing the error, that stage, the calling statement results in a runtime error. Because of that, the subsequent statement will not get executed. We can say that because of the runtime error reported in th.method, the statement will not, subsequent statement will not get executed. But you cannot say the statement will never get executed. There is a difference between the statement will never get executed or the statement will not get executed. Understand or not?
Yes, sir.
So you
Sir,
will
what
try
if
to
we have th dot method and th dot method consecutively inside the main class?
yeah, here you can see right the unreachable statement. I have removed that comment. Yeah, tell me what is th dot?
Method and th dot method. After that one, again. Inside the try block, we are calling method
Yeah,
again, sir. The second won't be reached.
th dot. I can't get you what you are asking. Th dot
Sir,
methods.
inside,
We are
after that, again, we are calling th dot method, sir. Will that be executed or not?
yeah, okay. Th dot method. Good question. Th dot method. Now in this scenario, right? Let us remove this. Now what happens? First stage, th dot method.
The same
Th
thing,
dot
the method will be terminated, no, sir. The statement will not get printed, no, sir. This, if you give both th dot method also, like before once it will get terminated, no, sir.
yeah, wait. In this case, right? Th dot method
Runtime
means
error.
runtime error. Here the runtime error is reported and handled here. Assuming throw ng, the runtime error is reported in the first call itself. So first call itself means subsequent statement will not get executed. The runtime error will be caught in this exception handler.
Or even if the subsequent statement has a different type of error, it won't be executed, sir.
it will not get executed. So that's what we have discussed in the last class. Once the runtime error is reported in statement X, the subsequent statement, right, even if there is no runtime error or if there is having different runtime error, subsequent statement will never get executed. It
Okay.
completely terminates the program execution. Or
Understood.
the corresponding error will be trapped in, handled or caught in the exception handling.
Understood.
Then we are moving on to the throws keyword. Java supports two types of exceptions. One is checked exceptions and another one is unchecked exceptions. The thing is, these exception categories are defined with respect to the compiler, right? So some compiler expects, right, some kind of exceptions must be mentioned in the throws class. Those are said to be checked exceptions. Compiler will not expect to see, right, some kind of exceptions need not be mentioned in the throws method declaration, throws class of method declaration or definition. Those kind of exceptions are said to be unchecked exceptions. The exceptions that we have seen right so far, say negative array size exception, array index out of bounds exception, string index out of bounds exception, null pointer exception, those are coming under the category of unchecked exceptions, where checked exceptions means the exception name must be mentioned in the method declaration following the method name. Say a return type, method name, parameter list. After that, you have to use this keyword or class CLAVST, right? So throws keyword, then mention what kind of error maybe or what kind of error, right, can be handled or can be raised inside that method definition. So for that, the general form of a method which changes further: return type, method name, parameter list, a throws exception list. A throws exception list is an optional one. Whenever a method throws some kind of checked exception means that must be mentioned in the throws class of method definition. So what kind of exceptions are all coming under this checked exception category means all exceptions, right, other than the error or runtime exception or any of their subclasses defined, right, are coming under this category, checked exceptions. In this stage, this is a role of compiler to check if that exception name is mentioned in the method definition, right? That is a rule. For example, the return type, the method definition, right, changes like this: return type, method name, parameter list, throws exception list. In case if the method would like to throw multiple exceptions, the multiple exceptions should be separated by the comma operator. Say exception class 1, comma exception class 2, comma exception class 3, etc. You need to specify the comma operator to list out the checked exceptions that may be raised within this method definition. All other exceptions, right, need not be mentioned here. Only what kind of runtime error may be reported inside this method name that may be mentioned in the throws definition. Some of the checked exceptions, right? Some of the exceptions, right, we will be using in later JDBC applications. Class not found exception. When we like to write load a JDBC driver, Java database connectivity driver. So when the specific class is not available, class not found exception will occur. Clone not supported exception. You know, object cloning. You can clone. That means you can create a copy of a object, one object into another one. So that stage, your method must implement the clonable interface. So if you fail to write define the clonable interface, that stage when cloning is not supported, clone not supported exception is rising. Instantiation exception, where when you try to create an object for the abstract classes or the extended classes, when it fails to redefine all abstract methods, again it become the abstract class trying to create an instance object. Instantiation exception is raising. Illegal access, right? Access to a class is denied, setting right something, the access rights of a class, and if you try to access something, right, illegal access exception. With respect to Java database connectivity, when you connect with the backend tables, when the requested field is not available, or when the requested method is not available, no such field exception, no such method exception. This kind of runtime error will occur. We have already explored, right, in unit number 1, IO exception. When we try to get a keyboard input value, right, using a readline method. A readline method throws IO exception. So whenever you are using the readline method, corresponding method must declare a throws IO exception in its definition, method definition. For example, here the method, right, throws illegal access exception. When accessing something, right, illegal access exception is raising. Here just we are illustrating illegal access exception for the purpose of a throws keyword. Void method throws illegal access exception. In this case, if you want to throw this exception, throw new illegal access exception. So the runtime error, illegal access exception is thrown out of this method using a throw keyword. Do not confuse here. The usage of throw does not require a throws, or even the usage of throws does not require the usage of through. In this example, but illegal access exception is this kind of a checked exception. If you want to throw, that is possible. Throw new illegal access exception. But illegal access exception comes under a category of checked exception. It must be mentioned here. Throws illegal access exception. If not, compiler reports the error message. Then inside the class, say exception 9, one object, say th is created, th.method, th.method, simply calling the method, we have this runtime error, illegal access exception. Then this will be caught in the corresponding exception handler, catch. Then the next line, right, end of line will get printed. This is just one example to illustrate what is the checked exception. Another kind of checked exception, another example for checked exception we have discussed earlier using IO exception class. Java exception, illegal access exception, runtime error is throw using a throw method, sorry, throw keyword. That error is caught right in this exception handler and will be the error is recorded inside the main methods exception handler. In case, right, if you do not worry about, right, throwing this kind of exceptions directly, right, you can mention throws, for example, IO exception, because of the code reader class object name dot readline method throws IO exception. That stage, the IO exception must be mentioned in the throws class. In case, if you want to call the same method here, and inside the main method means main must also define a throws IO exception, because the caller of the method must be safeguard against the checked error. That stage, this method must be throwing illegal, sorry, throws IO exception. Here main method must also use the same form, throws IO exception. Already we have explored, right, using the IO exception illustration. Having any queries in this? Last line, throws need not require the use of throw in a Java program. Better example, IO exception. Then one more keyword, that is a finally keyword. Finally, it can be associated with a try block or a try catch block. To understand when do we need a finally keyword, you try to understand this scenario. Suppose here we are opening a file. I think you might have studied the concepts of files in C and C++. Assuming that right using a open statement, for example, here we are opening a file and we are processing the file. Assuming these are some statements to process the corresponding files. When we are processing the files, assuming that here a runtime error is reported. Because of that runtime error, subsequent statements will never get executed. Program is said to be abnormally terminated. Then, following the file processing, here file close operations are carried out. File close operations will not get will never get executed because open to file is processing, right? So when the open file is in processing, what will happen means because of the raised runtime error, program termination is abnormally done. Abnormal program termination will never come back to execute the file close operations. In that stage, we need to properly close the file, right? This is one issue. Another one, in case if you want to establish a connection with some network resources, here you can define in a method, for example, connection establishment. After connection establishment, you can perform some of the operations. During the processing of the operations, assuming that a runtime error is reported, before closing or before releasing the established connection, runtime error abnormally terminates the program execution. So abnormal behavior will be possible. So to avoid that, what we have to do means we need to define a finally block with this general form. Finally, then opening curly brace, closing curly brace, some set of statements to be written. So this kind of contingency problem is resolved using a finally block. So what can be placed inside the finally block means better to place the code related for closing a file, releasing the connection establishment, right? Releasing the network connection, or releasing some network resources, IO resources, something. This kind of operations can be defined inside the finally block. The question is when finally is called, how this kind of contingency problem is resolved using a finally block. For that purpose, right, we need to have a try catch block. To introduce a finally block, either you have to define a try block, try, opening curly brace, set of statements, closing curly brace. Then define a finally block. If not, define a try catch exception handler as usual. Try exception handler, right? Catch one or more exception handlers. Following the last catch exception handler, define the finally block. That finally is associated for the corresponding try block. Try, following that multiple exception handlers, then define a finally block. So these are the two ways in which we can define a finally block. A try catch block may have a finally block, may have, right? So optionally, it can have a finally block. If required, right, we can define a finally block. But in the previous examples, right, we didn't have a finally block for the each try catch block. A try block without a catch, because of that, right, I already said. So try, right, requires a catch block. In case when a catch block is missing for a try block means it must have a single finally block. Try some set of statements. Assuming that exception handler catch is missing, then the try block must have the equivalent finally block. Finally, opening curly brace, set of statements, closing curly brace. So finally is right anyhow the optional block for the try catch statements. Optional in the sense that if you require, we can define the finally block. If not, we can omit the finally block. How the finally block will get executed, right? We have to learn the different situations when finally block will get executed. Finally will get executed after the try catch blocks a complete execution before the control goes to any sequential execution. To illustrate this scenario, consider a try block, then catch block is defined, assuming that the runtime error is caught in the catch exception handler. Following that, what will happen? Sequential execution is going to be performed. Before continuing the sequential execution, but after the complete execution of the catch block, finally will automatically executed. This is rule number 1. Second rule, finally block will be executed whether an exception is thrown or not. In the first case, exception is thrown. There is a successful match. So after the catch block, finally will get executed. That's what we are asking return. To try to place the file closing statements, releasing the network connection statements, some other releasing IO resources. These procedures can be placed inside the finally block. Second one, finally block will be executed whether an exception is thrown or not. Suppose a try block, no runtime error is reported inside the try block, then catch will never get executed. When the control comes out of the try block, automatically finally gets executed. This is rule number 2. In case when an exception is thrown for a successful match, after the complete execution of the exception handler finally will get executed. In case when there is no match between the raised exception and the exception handler, before Java tries to execute the default exception handler, finally block first gets executed. This is the third rule. During a mismatch, what happens? Before the execution of default exception handler, that means before terminating the program execution, finally will get executed first, and then abnormal program termination is possible. This is rule number 3. Last rule, in cases you like to transfer the control unconditionally to a calling method, having a no runtime error. For example, simply return statement. A method may return some value to the calling place. That stage, in case if we introduced right the try block means that stage before the control is returned to the calling place to execute the subsequent statement or to make some assignments. That stage, after the complete execution of finally block, then only that operation is taken place. This is rule number 4. Let us illustrate right these 4 rules within this example. Say class finally using one method A is defined void A. Inside void A, have a look into this error. Throw new runtime exception, runtime error. That means the runtime exception. This error is thrown using a try block. We defined the corresponding catch exception handler. Runtime exception E, the error is processed here. Then throw E, what happens? The error is rethrown to the calling place. So before the error is rethrown to the calling place, this is rethrow exception E. Rethrow the instance E. So before the instance, right, or error E is right rethrown to the calling place. Since this try catch associates this finally block, finally will get executed first. After that, what will happen means this runtime error is rethrown to the calling place. So finally, it seems the word finally, but here finally is executed first, and then the error is rethrown to the calling place. And then a second rule, right, to illustrate it. Here try block is there, no runtime error is reported inside the try block. try catch is missing, a finally block is given, say inside B is finally block. So when you call a method B, what happens? This line will get printed. Then before continuing the sequential execution, because this finally is associated with this try, the finally block will get executed. Then third method, say void C, one try block is defined inside C, return. What is return? A dummy return. Unconditionally, control is returned to the calling place. No value is returned, right? Dummy return. This try associates a finally block before the some values returned to the calling place or before returning the control to the calling place or even whatever the value that you are going to return. Suppose int C return 25. Before the value is returned to the calling place, finally is executed first and then the return statement is executed. Then method D, we are raising this runtime error, divide by 0 error. Assuming that the divide by 0 error is caught in this exception handler. After the successful match of this exception handler and processing this one, control goes to execute the next statement in the sequential order. So before that, right, what will happen means finally will get executed. Exception is raised, exception is processed in the exception handler, finally execution first, and then the next statement. In case here, assuming that array index out of bounds exception is defined, there is a mismatch between the raised error and this exception handler. So before terminating the program execution, finally we get executed, and then abnormal program termination is taken place. Then you will not see this message end of D in case array index out of bounds exception is placed. If not, divide by 0 error processed here, line is printed, then this line is printed, then a sequential execution following this, the method D goes to execute the next method. For example, here, system.out.println end of D. So these are the 4 different situations in which finally will get executed. We are creating the object for finally is the user defined class in the try block. Since here runtime error is reported here and it is rethrown to the calling place. Before the error is rethrown to the calling place, you can see the message inside A is finally blocked, and then the rethrown, right, the error that can be rethrown from the calling place, right, from that method corresponding to this runtime exception. There is a match. Now you can see the message runtime error in main. The error that you are rethrown is processed or caught in this exception handler. Then object.bcd. Finally, you can see the message end of main. Let us check the code. First, what happens? We are calling object.a. In A, the message to be printed is inside A. Then throw new runtime error. Runtime error is printed here in the second line. Runtime error. Runtime error in sorry, what is second line here? Runtime error. Java.lang.runtime exception runtime error. Then what happens? Throw E is there. Throw E rethrows an exception to the calling place. Before the exception is rethrown to the calling place, third line you can see the message inside is finally blocked. So here inside is finally blocked. And then this error is rethrown to the calling place. Here this line results in a runtime error, say runtime exception. This is caught in this exception handler. So you can see the message runtime error in main in the next line. Runtime error in main. Then calling a method B. In method B, catch exception handler is missing. Try associates for a finally block. So after this line inside B, then inside B is finally blocked. So next 2 lines inside B is finally blocked. Then calling C, Inside C, before the control is returned to the calling place, we can see the message inside C is finally blocked. Next two lines inside C is finally blocked. And then we are calling a method D. In method D, the divide by zero error is processed in this exception. So divide by zero error, then divide by zero error, then the sequential execution finally is executing. Inside D is finally blocked, then end of D. Inside D is finally blocked, end of D. Then the next line in the main, end of D. In case here the raised error mismatches with the exception class, what happens here finally is executed first, and then the default exception handler terminates the program execution. This is the rule for the execution of finally block. At four different situations, finally block will get executed. Having any queries in this?
Oh, sir.
Okay, the last one is how to define our own exceptions. User defined exceptions. User-defined exceptions in Java is possible. To define the user-defined exception, first step what we have to do is we can define our own class. That class should be a subclass of a superclass exception. For example, class our own exception extends a superclass exception. Then our own exception in that class, right? What you have to do means you need to define the constructors, and you need to properly define a toString method, because when you print the instance of the exception class name, a toString method is automatically called. ToString is a method which is defined in every class. That means you are overriding the toString method and printing the object instance. A toString method is called. You see this example so that you will understand how user-defined exceptions in Java can be written. Problem is this one. Define the user-defined exception class, minimum deposit exception. This exception should be raised when the user enters a deposit amount which is less than, say, rupees 50,000. So when the user is trying to enter the deposit amount for a banking calculations, if the deposit amount is less than 50,000, for example, we try to raise this runtime error, minimum deposit exception. So for that purpose, what we have to do means you need to define a class minimum deposit exception extends a superclass exception. Then define the constructors. For example, minimum deposit exception. This is a user-defined exception. Then our parameter, right, A, this is assigned to the integer variable. Then override the string method, public string or toString, assuming the message to be returned is string message, minimum deposit error, and the value, right? Say if you enter 40,000, minimum deposit error 40,000 is returned to the string message. When you print the object instance of minimum deposit exception, the toString method is called, right? I tell you. The next class, say class interest call. Here, void compute interest. We are passing the principal amount here as the value of Q. The method throws minimum deposit exception. So in this case, you need to properly define the throw statement. Throw new minimum deposit exception, because all user-defined exceptions are also a subclass of throwable. We are satisfying the rule of throw keyword. Throw new, then class name. Class name should be a subclass of a superclass called throwable. If the interest amount is less than, as suppose if the interest amount is greater, sorry, principal amount is greater than or equal to 50,000. Here you can write the subsequent statements, right? No problem. If Q is less than 50,000, we are raising the runtime error, say minimum deposit exception, following this. If, right, a conditional test, if this is true, we are throwing this runtime exception. else, then control comes here, computing the simple interest. Now right here you can continue the code to process the simple interest calculations. Inside the main method, object for this class interest call has been created. Then we are trying to call the compute interest method by passing some actual parameters, say 75,000, 85,000, 5,000 and 50,000. When the actual parameter is 5,000, what will happen means here Q receives the value 5,000. Condition is true. Throw new minimum deposit exception of Q. Q is right, say 5,000. Minimum deposit exception of 5,000. Here the constructor value A receives 5,000. X receives 5,000. Minimum deposit error 5,000. This is a string message. The string message is output when you print the object or when you print the instance of minimum deposit exception. So compute interest of 5,000, which results in the runtime error through new minimum deposit exception. That runtime error is caught in this exception handler. So here you can see the message minimum deposit exception in main MDE. MDE, what will happen means the toString method is called. If you put twice the toString method here, minimum deposit error 5,000 is appended twice. Then the end of main method. So only thing you need to define your own exception. That exception should extend a superclass called exception. Define the constructor, define the toString method. Then in the real usage, inside the method definition, introduce the throw statement. Throw new, the user-defined exception, parameter list if required. Then since the minimum deposit exception, these are some unchecked these are the which kind of categories, right? These are the checked exception categories, right? Compiler tries to check if the method is going to through the user defined exception. So all user defined exceptions must be mentioned in the throws class of method declaration. I show this output Java C exception 11.java Java exception 11. For the first case, which one here? 75,000, 85,000, no problem. Right? A simple interest calculations can be done. You can compute the simple interest for 75,000 and 85,000. Then for 5,000, what happens? 5,000 is passed as a parameter here. Computing simple interest, the Q is greater than or equal to 50,000, message is output. But here, throw new minimum deposit exception, 5,000. So runtime error is reported here, this line. The runtime error is printed here using this exception handler. So next line you can see the message minimum deposit exception in main. Printing right the value MDE one more time, right? Twice I have given because to check if a toString has been actually called. So twice you can see the message, right? Again, minimum deposit error, right? Say 5,000 in main. After that, right, what will happen means the next line uh, end of main method, and this will get executed because this line results in a runtime error. Control will never go to execute the subsequent statement 50,000, right? This will not get executed. So likewise you can use this exception in this usage. Suppose you can accept a method, right? It is design a method to find the maximum of 5 numbers, assuming the user input is entered right through the keyboard. Define a custom exception, 5 marks you need to enter. In case if you try to enter a negative marks, right? So that stage, your program should be protecting the negative input values. So writing a dependency program that accepts the positive values, you can design the negative mark exception. How to design the code? Class negative mark exception extends exception. You can define right something mark here variable declaration constructor or toString method. class max 5. Suppose here you want to get input values, right, from the keyboard. That stage, right, checking if input is less than 0. Formally, I have written the procedure. If any input, right, mark is less than 0, here you can write the throw statement. Throw new, then class name, negative mark exception, or negative keyboard input, or negative input mark exception. Then int. Inside the main method, you can call the object of this class and call this method max5 method. Then define the exception handler, say same exception handler, negative mark exception, and this may be processed in this exception handler. So this way user-defined exceptions can be written in Java. All user-defined exceptions are the subclass of a superclass called exception. In such a way, the user-defined class is written. Define the constructor if necessary, and define the toString method if necessary. Then use the user-defined exception in a proper usage of throw statement by checking some conditional. A throw new user-defined exception parameter list if required. That is a real usage of using user-defined exceptions. In the recent versions of JDK, multiple exception handlers can be defined in a single exception handler. For example, here we can write catch minimum deposit exception, then pipe symbol, that is OR symbol, array index out of bounds exception, or arithmetic exception. Likewise, multiple exception handlers can be defined in a single exception handler. But the thing is, if you define the separate exception handlers, right, there will be no confusion, right? So try to have the separate exception handlers for each of the exceptions. With this, we are completing the object-oriented exception handling framework. If you have any queries, you can ask. In the next session, we will focus on multi-threading. Okay, thank you very much. We will discuss in the next session.
Thank you, sir.
Thank you, sir.